Hey everyone, welcome to our Azure Storage module of the V3 Masterclass. And this module is really all focused around the functionality of the Azure Storage account, this building block that many other things in Azure actually build on. So we look at the capabilities of Azure Storage, some of the capabilities of virtual machines, which again are a fundamental building block of what many of the other services in Azure are built on, and then some of the storage tools. Now, when we go ahead and think about the types of storage that we have in Azure, we have various considerations. And we'll talk about things like durability. That's the ability to preserve data over time. Latency, how long some certain operation takes. And remember, latency is a function of both maybe the distance between me doing the operation and the actual storage, and then the storage itself doing that operation. In the old days of hard disk drives, you had this seek time as the head had to move to the right spot. With SSDs, there is no seek time, but it still takes an element of time to perform operations. And then we talk about things like the structure of the data, etc. So, different workloads have different needs for different types of storage, both ephemeral and durable. So when we think about ephemeral, it's kind of, it's there for a moment in time. It's temporary, it's volatile. This could be I'm using it for some cache type purpose. It might be something I just use maybe to store a page file on. But if I lose power in whatever compute workload I have, I would lose the content of that. When I think about durable, it's persistent. This will be stuff I want to keep. It has to be stored on some type of long-term media, typically a disk, but maybe even tape. Now, there are various types of data available that vary greatly depending on what my application needs from that data. So if I think for a second about the various types of data. Now, one of the things we commonly talk about is unstructured. So if I have unstructured, this could be something like, hey, I need to store a media file. It could be an image, it could be a video, just some unstructured piece of data. So really, I could store anything there. It could be a binary, for example. And then we think about structured. And when we think about structured, we're typically thinking about a database, because this would have some schema. Now, the schema describes what are the various tables we may have, what are the columns, i.e. the attributes of the data, and what is the type of that data. Is it a text field that's 16 characters long? Is it a floating point? Is it a binary? So you're going to have this fixed schema, and then the data we put into a particular table has to adhere to that schema. So it's a very rigid format. And we'll see that a lot in relational databases where we will normalize the data. So we'll be very efficient with how we store that data. We'll have relationships between different tables. We might have foreign keys. So this particular element within a database, this record, relates to another record in a different table. So it lets us get very efficient with how we store the data. And then we have documents. We think about semi-structured. And this is often self-describing. So there isn't a traditional schema, but what we'll have is something like an XML file or a JSON file. So it describes its own structure within it, but we can have a mixture of different structures within a particular document. So these are very common types of data that we're going to see today. Now, another thing we might see as part of these is we need different capabilities. So, for example, indexing in a relational database is really important, maybe even in that semi-structured inside documents, because I want to be able to go and interact with a certain record. And if I have a huge amount of data, I don't want to have to trawl through and find the particular record I care about. So we can have one or more indexes that make it very easy to go and find certain records based on the particular columns, the elements that we have chosen to be indexed and then easy to very quickly interact with. We may want snapshots. the idea that we can take a certain point in time of the data. I may need it to be able to replicate between maybe different regions, different instances, on-premises to the cloud, whatever that may be. And then we'll also have different types of API, application program interfaces, ways one application can talk to our data. There may be different protocols we want to support. Block level, where I actually see the blocks on the disk and then I manage the file system. Or we have file-based, where I talk to some API and I just deal with the files and the folders. So we have different requirements depending on what I need to do. And there is not one best answer here. And very typically, your application will use multiple different types of storage because you're going to have different requirements for different parts of your application. So different use cases will lean towards different types of structured data or unstructured or semi-structured. I might need ephemeral storage. Remember that temporary for caching purposes, but then I need durable for the long-term state. So there's not a best. It's really going to come down to, well, what is my particular requirement for this element of what I'm trying to solve? So let's talk about Azure Storage. So Azure does not use traditional storage area networks or network attached storage solutions as we think about in a data center. In our data centers, we have these big SANs with lots of fiber connections. That does not exist in Azure. Now, I'm not including Azure NetApp Files, which we will talk about later on. That's really the only solution where we actually have NetApp filers sitting inside Azure data centers. But for Azure Storage, it's these special storage stamps, so clusters of storage servers that provide the storage services. They do not use traditional SANs. It's all focused around software-defined storage. And these storage services we have powered by Azure Storage are leveraged by pretty much all of the other capabilities of Azure. You have these hierarchies of things that build. So you have Azure Storage at the base level on these Azure Storage clusters. And then databases, the Azure Database Services, will use that Azure Storage. Even more advanced services like Azure Key Vault, well, it's using Blob under the covers. So these things all build on top of each other. And so if Azure is using its own storage architecture with these storage clusters, what it's actually using is this 3-tier architecture. And this provides all of the scale, the capabilities, the replication that we need. And it's actually built on the work they did for Bing, so Cosmos, for part of the replication. So we have these storage stamps. So a storage stamp is n number of racks within the cluster. And you have these different fault domains. You have redundant networking and power. You will get special types of storage stamps. For example, the premium offerings, they want a different type of storage stamp that has a different type of disks. But at the bottom of our hierarchy is the stream layer. And you can think of the stream layer as the actual bits on the disk. So this is responsible for the distribution and replication of the data across the servers in this particular cluster, this stamp, to make it durable. And so this stream is just an ordered list of storage chunks that are made up of various blocks. And then we have the partition layer. Now, the partition layer understands the constructs that we interact with. So it understands abstractions like blobs and tables and queues. It provides a nice scalable namespace. And then, of course, we want to be able to interact with this, so you get the front end layer. So these are really stateless, that they just take the requests. So they take in that API request, it looks up the account name, it does the authentication, then it routes it to the partition layer, which will then, hey, go and take care of that durable actual storage. Now, DNS, domain name services, is used for really everything that we see in Azure to some capacity, but it's the namespace for my storage account. So what you'll see is you always want to use encryption, so it's going to be HTTPS. So I'm using TLS 1.2 or above. Your account name, the type of service, so blob, file, queue, table, core.windows.net, and then the partition, which the partition is going to vary depending on the type of service, and then the actual object I want to interact with. So if I jump over for a second, if I go and look at just one of my storage accounts, And we can see the various endpoints that I have available for this particular storage account. So under my settings, I can see my endpoints. If I go and look at my endpoints, I'll see exactly what I just described. So if I think about Blob, for example, there's HTTPS because I want that TLS encryption. That's my storage account name. I'm currently focused on the Blob service, and then it's core.windows.net. Then if I started going and looking in particular containers, etc., well, that would then follow the URL. Notice I also have a secondary endpoint for Blob. If I go and look at file, well, then the name of the file has file between my storage account name and core.windows.net. Q has q.core. And both queue and table also have secondary endpoints, just like Blob. Only file does not have that secondary endpoint. Now, the use of those secondary endpoints will make more sense in a little bit. But fundamentally, what we have here is data is replicated in two ways. We always have 3 copies of the data in our home region. And that replication within our region is done at the stream layer, and it's synchronous. I.e., there's some client is talking to the storage account. It says, hey, write this data for me. It doesn't get the acknowledgement back until it's been durably stored in those 3 copies of the data. And that could be zone redundant if I pick that as the replication. So they're actually split over the 3 AZs within the region. And then if I'm geo-redundant, and we'll dive into some little bit more detail around this. If I'm geo-redundant, well, then there's another 3 copies in the paired region, but that's asynchronous, which means obviously that those 3 copies are done in the background as quick as it can. But in an unplanned disaster scenario, well, maybe some of that data gets lost. But I still have the 3 copies in my region. So there's 6 then in total. So let's look at those storage account constructs. And as we saw, the top level namespace is the storage account for all of the various storage services we're now going to see. It is created in a region. Like pretty much every resource in Azure, it lives in a specific region and a resource group. If we jump over for a second and just look at this storage account, well, we can see, yeah, I exist in a certain location and a certain resource group. If I wanted to actually create a new storage account, well, we have to give it a name, but I have to pick a resource group and I have to pick a region. So those are really some of the core things that I have to give as part of this. Now, there are actually different types of storage account. The portal kind of hides these a lot from you today, just asks you some general questions about, hey, what are you going to use this for? And then it does ask you for performance. But if I'm using the CLI, if I'm using templates, I have to specify the exact type. Now, we have things like standard and premium performance, which changes that back-end storage stamp used to provide the higher performance. From a storage account type, we have general purpose v2. Now, that is what we use for most general things. It supports blob and queue and table and files. So that's typically what you're going to leverage. But if we pick the premium offerings, then you get into these very specific types of account that only support a particular type of service. So if I do premium blob, well, then it's going to use blob storage. If I use premium files, it's going to use file storage type of account. Or if I actually use provision v2. If I pick page for premium, well, then it's page. So depending on what I pick, it's going to drive that particular type of storage account. So here we can see we have these options. Notice it's asking me a question. Hey, what is the primary service you want to use with this? So I say, hey, I'm going to use blob or files or tables and queues. Now, if I just pick blob, notice it's saying the performance is still standard, which means it's going to use that general purpose v2. But if I flip this and was to pick premium, Well, now it's going to be a particular type of account. And here I can pick for that premium, hey, is it block blobs, file shares, or page blobs? Additionally, if I pick West US 2 and I pick files and standard, you'll actually notice it's giving me this other option of how I'm going to get billed and how I can handle the performance. So if I pick provision V2, then it will again create a file storage account of V2 provisioned. So there are some specifics that go on behind the scenes. The portal abstracts a lot of it for you. But if I'm actually using templates or CLI or REST API, I would actually have to understand those various options available for me. But just kind of know that is there. And then, so I pick the SKU, I pick the performance. Then we have different types of resiliency. Now, these are going to offer different SLAs in terms of its availability to interact with the service, SLA in terms of the ability to read from it, SLA to write to it, and then completely separately, there's things about the durability. Now, remember those different partitions, the different layers. Imagine that front-end layer was having a problem, so I can't interact with my data. That doesn't mean I'm losing data. The data is still highly durable on the disk. So if we go and look at the durability for a second, this is the chance of actually losing data. So even LRS, just those regular 3 copies, they have 11 nines of durability. I don't think there's ever actually been data loss in Azure. If we pick the zone redundant, well, now it's 12 nines. The durability, the chance of losing any data. And I think if you, I'm sure it shows it somewhere. There, GRS, 16 nines of durability. So you basically get these silly levels of durability, but then that doesn't mean I can always interact with it. My data is safe, but can I actually interact? And that's where the ability to maybe have those additional copies replicated in different places, to maybe be able to always interact with my data. Well, that can vary. There's LRS, GRS, ZRS, GCRS. There's alternate options. If I pick, for example, GRS, I then have this option to give me read access to that secondary copy of it, even if I don't have kind of some regional problem going on at that moment in time. So we have all these different resiliency options. Now, again, the key point to remember here is these are about the ability to interact with the data. This is not risking the durability of the data, but as you saw, the durability does increase, which makes sense if I think about, hey, the more I spread out my data or have more copies in like 2 regions, well, I get an even better assurance that my data would be available. So let's dive into those different options we have and really what that means for the storage of my data. Now, I'm going to focus initially within a particular region. So this is region 1. And when we talked about those storage stamps, those storage clusters, let's initially just focus on one of them. So I've got a particular storage cluster. Now, if I pick the locally redundant storage option, remember with locally redundant, there's always 3 copies of whatever data you have. So that is LRS. But those 3 copies are in the same storage cluster. The next option is ZRS. So now remember, we have the option of the 3 availability zones we have in any one place. So now let's say I've got AZ1, AZ2, and AZ3. So with ZRS, now what it's doing is it's still just 3 copies, but those 3 copies are now being distributed over storage clusters in the 3 availability zones. So I've got an even higher resiliency of my data. Remember, the durability went up a little bit, but also those different storage clusters, well, they have those different front-end services. So my ability to interact should be increased as well, because now I'm resilient if just one of them had some failure going on. But now remember, we do have those pairs of regions. So now imagine, I'm just going to do a little bit less drawing, I have region 2. And in this specific case, this is the paired region. This is where Microsoft picks those pairings. They have designed them, so there's a big distance between them. And this is used by storage accounts. So now we have the option of GRS. So if I do GRS, well, with GRS, I have the 3 copies within a certain storage cluster. And then so remember that these are all synchronous. And now what it's going to do to a certain storage cluster on this side, it's going to asynchronously replicate, and there'll be 3 copies within a specific storage cluster on the other side. And then finally, there's kind of a hybrid of all of these things, and I can do GZRS, where it's a combination of ZRS and GRS. So on the primary region, the 3 copies are distributed over the 3 AZs, but on the paired region, the 3 copies are still within a single storage cluster. It is not ZRS on the other side as well. Just important to understand that. And then for both of these, for the services, you have this optional choice. There's a little bit of I pay a little bit more money, but then I could say, and actually what I want over here is the read access to it. And that's where, remember I showed you that second endpoint? I can use the secondary endpoint to talk to the services in this region to maybe go and read from those services. Now, it doesn't work for Azure Files, but it works for Blob, Queue, and Table. So I have those different capabilities available to me. Now, in a real failover, that primary endpoint will just now point to this one. Realistically, I don't think Azure has ever had that happen. They've never done a full regional failover. So there were actually some changes coming around that, and I'll show you this in a second. But yes, you're not going to have that secondary endpoint for files because it does not support that. Now, you can switch between like LRS and GRS, and there's some special steps for the ZRS stuff, but you can absolutely manage and change that resiliency. You're not locked in because that's what I picked when I created the storage account. From a cost perspective, obviously, as I move down these, they cost more money. ZRS costs more than LRS. GRS costs more than those because there's 6 copies instead of 3. GZRS costs more than GRS because those 3 are spread over the AZs and that. I also pay for the data egress because it's going out of the region. So there's some data transfer charges involved in that scenario as well. Now, I mentioned that Azure has never had a full regional outage. So they have never actually done this failover thing. But imagine there's some maybe smaller scale issue that's impacting you. So what they do give you the ability to do now is customer managed failover. So if I go and look at storage account, now firstly, I can see my redundancy. So I see data manage redundancy. I can select that. And it will show me what I have. So this is GRS. So I can see, look, it's geo-redundant. And notice it's giving me some options here to change between them. ZRS, as I mentioned, there were some special things to be able to switch to ZRS. But it shows me my primary and my secondary. It shows me a nice little picture of where they are. Now, one of the things I can do here is I have this prepare for failover. If I select this, I can do an unplanned failover. Now, what this is doing is it's showing me when is the last time these were synchronized. If there was data after this time, well, then I would have the potential to lose that data. And you'll notice there's this planned option, which is grayed out for me. That is in preview. So the difference here is when I perform an unplanned failover, what this will actually do is the secondary would become the primary, but it would become LRS. It doesn't reverse those things. So I would then need to actually go and then turn on GRS to reverse it back the other way. Planned, that preview functionality, is only available in certain regions, not the ones I'm using, but it would actually swap the primary and secondary. So it would keep it as GRS and it would reverse the flow of replication. So that would obviously be a really nice capability to do. But just realize you have the ability to actually do that customer managed failover. So Azure is not raising a regional outage, but maybe they're saying there's impacting my service. I can choose to do that customer managed failover. There are APIs available to actually go and interact with the services. So that's the ability in those SLAs to actually be able to talk to the various data. And there are different options depending on, well, what is the actual service I'm using. There's always kind of these base APIs, and there's ones for Blob and queues and tables. But then additionally, imagine files. Well, files, I can talk to it via SMB. It's a file-based protocol. I can also use NFS. I can use NFS for Blob as well. I can use SFTP for Blob. I can use HDFS for Data Lake. And we'll talk some more about these, but they will vary depending on the actual service I want to talk to. Now, the capacity, the IOPS, the throughput vary based on a lot of different things. What SKU I picked, what performance I picked, maybe specifically, did I use the pay-go or the provisioned options? And we'll go into some more detail about that. But realize there are some differences in what I get out of the performance depending on those options I choose. And obviously, when it's like standard versus premium and performance options, obviously that impacts the performance I'm going to get for that service. But I always pay differently. So whenever you think, oh, it's higher performance, you're going to pay more money for that. When I think about some of the provisioned options, though, maybe I've got a better consistency in what my bill will be, and that might mean more to me as a customer than paying the minimum, but hey, I get these varied bills. I'd rather have consistency in my billing. Additionally, some different services have tiers available for them, both Blob and files. So with Blob, I'll see there's a hot, a cool, a cold, an archive. With files, I'll see a transaction optimized. I'll see a hot and a cool. And this lets you balance the need to store and have the data available with how much you intend to actually interact with the data. Typically, over time, you'll have older data that you still need maybe instantly available, but I know I'm going to interact with it less. So what these tiers let me do is shift to say, look, I'll pay less for the storage of the data, but I'll pay more when I actually need to go and interact with the data. So for really new data that I intend to interact with a lot, maybe hot is the right option or cool is the right option. But when I just have data that's just there, but I need instant access, well, maybe cold is the better option, so I know I'm going to do less operations against it. So it's about you being able to optimize your build for this. And I can enable monitoring and logging. There's different metrics available for the different services. I can use diagnostic settings to control, hey, I want to send these logs to these different services, be it storage account or an event hub or log analytics workspace, to give me insight into actually what I'm doing. And the granularity can vary. If we jump over for a second. So here, if we scroll down, we can see we have logs and we have metrics. So if I select metrics, for example, there'll be metrics for the account level. Then there's metrics for the particular services. If I'm on a particular service, for example, then maybe I'll pick Blob. And then for Blob, well, there's Blob capacity, container count, the types of transaction you're performing against it. This is what I pay money for. Depending on what I pick, I can aggregate it over different things as well. So let's say my availability. Well, I can do average, minimum, maximum. So I have choices on exactly what I want to do. So those metrics are going to vary greatly depending on the specific service. So just realize you have really good ability to get insight into what's happening on your storage account, which obviously you're going to care about because you're going to pay for those capabilities. I want to talk on object level replication, because obviously those paired storage accounts we talked about, maybe I don't want to use the paired regions. Maybe I want some more flexibility in actually what I replicate. So object level replication lets us do that for blobs. Now what it's doing is for block blobs or containers, what blobs live in, it enables us to be replicated to a container within another storage account of our choice. Now it's using a couple of features we'll talk about later on called change feed and blob versioning, which really just lets us track the different versions if a blob is being changed. And then the change feed is, well, when did those changes take effect? So it's a way to be alerted to say, oh, look, the blob has updated. The blob has been changed. So I can say, oh, the blob has been changed. What's changed? Oh, I need to go and send that block somewhere else. So this is only for block blobs. This is not for append. This is not for page. And really the way this is going to work is going to give you all of the flexibility into how this gets replicated. So remember, this was this hard link in between region 1 and region 2. They were paired regions. So now what we're going to think about is, well, I just have a storage account. So I've got my storage account 1. And in that storage account, we're focusing on the blob service right now. But I'm going to create 2 containers, which is what I then put the blobs into. So I've got a container 1 with some stuff in it, and I've got a container 2 with some other stuff in it. And then, well, in one region, a different region, not the paired region, it could be if I wanted to, but it doesn't have to be, I've got a completely different storage account. So whereas this is basically the same storage account when I'm using the paired region, this is a completely different storage account, completely different endpoint, its own thing. And I create another storage account. And in that, I create another container, container 3. Maybe in another region, I create another storage account 3, and I create another container over there. And what object level replication lets me do is I can say, well, actually, from this container, I want you to replicate to this container in this storage account over here. For this container, I want you to replicate to a completely different storage account into this container over here. Now, it's going to be asynchronous replication again. This is not synchronous. It's not guaranteeing, hey, I do a commit over here. It won't acknowledge that commit to the application performing that until it's copied here. It's asynchronous. There's a distance between these things. I don't want synchronous. It would cripple the performance. But remember, it's using that change feed to know when something happens, and it can use the blob versioning to work out what has changed and have the version it needs, so it can copy that thing over. What's nice about this, though, is because it's this object level replication, well, I can do things like filtering. So I could apply a filter as to what I actually want to copy. Another thing I can do here is it's going to work for premium block blobs as well, whereas traditionally there's limitations to what I can do with premium. So it's not just general purpose v2, it's premium block blob accounts, but not if I have data lake turned on. So there's different features, and we're going to talk more about the data lake, but this object level replication is not for hierarchical namespace. It doesn't align to the regional pairs. As we talked about, it can be any region you want. I have flexibility in which blobs are replicated. So I can specify a prefix that must be matched for the blobs if I don't want to send all of them or only want certain things to actually go over there. I can have a certain number of rules within a policy, but I can only replicate to one place. That's kind of a key point over here. And one of the nice things is I can use different tiers for the source and the target. So I could be hot maybe on the source side, but maybe cool on the target side. So that gives me a lot more flexibility within those things. If we jump over, so if I maybe just look for a second at object replication, I could go and create a replication rule. I would pick the destination storage account. I'll do one in the same. So I would pick the source container on my side, the destination container in the other storage account. I could add filters, so I could add a prefix match. I can then control, well, which objects? Is it only the new stuff? Is it everything? Is it some custom, so only things that were created starting from a certain date? So we get a nice selection of options for this, but it gives me now flexibility. I don't have to go and align to those storage account pairings, which we normally have to do. But remember, it is using the change feed. It is now going to require transactions to be used. So it's going to be reading, it's going to be writing, and I'll have to pay for that. I'll have to pay for the network egress. So there, don't forget to work out all of the costs associated with this. So let's look at, well, what are the actual storage account services available? Now, when it's general purpose v2, they are all available. Remember, if I pick one of those more specific ones like Blob or page or files, then it's only going to support that one particular service. So Blob. Blob is our probably fundamental type of object that nearly everything uses in Azure. It's really useful for very large amounts of unstructured data. Now, there are different types of this. So the big thing we really think about when I think of Blob is Blob. So with Blob, this is different size blocks basically formed together to create what is this Blob. And it's useful for storing anything. Now, by default, Blob is a flat namespace. And what I mean by that is there is no concept of directories. Now, you're going to say, that's not true. I've seen directories when I've played with Blob. You've seen virtual directories. The way that works is it basically adds in the directory name as part of the name of the Blob, but it doesn't actually understand them. Whereas, when I turn on the hierarchical namespace, HNS, this is what the Azure Data Lake Storage Gen 2 is. It sits on top of Blob, but now it adds a true hierarchy to that. And then when I turn on the hierarchical namespace, then I can get other capabilities available to me. For example, one of the things we have is something called NFS. So NFS is a different type of protocol. So NFS 3 lets us then actually go and get capabilities around ways I can interact with the Blob. Now, I can only use it from a certain network that's connected to it. And I have to have, again, that hierarchical namespace enabled. I can get SSH FTP. So it's going to get me encrypted FTP services too, again, when I have that data lake enabled for me. So there's some really nice capabilities. So if we think for a second about the services, where can I draw? So we start from here. So imagine this is a storage account. So there are many types of service available to that storage account. Blob. So when I'm dealing with Blob, we have containers. So containers is the structure into which we then put our blobs into. Now, if I enable the hierarchical namespace, then we actually have true, these become folders. And what we're going to store in here initially is a block blob. That's the most fundamental type. And again, that is a flat namespace. There are no true directories within that. But if at time of creation, I pick to turn on the hierarchical namespace, then it becomes a data lake. This is what the ADLS Gen 2, my hierarchical namespace, is leveraging. And when I have the hierarchical namespace, well, then we get features like NFS 3.0, and we get features like the SFTP. But I have to have turned on the hierarchical namespace to then get those capabilities. Now, there's different capabilities I get depending on those things, but it's basically adding additional APIs. So, hey, I can use the Blob REST API. I can use here the Data Lake API. Hey, I can use the NFS ways of talking into it. I can use the SFTP ways of talking to it. So I just get more and more flexibility in ways I can interact with the service. And once again, if we go and look, if I was creating a storage account for a second, one of the things we'll kind of see, if I just leave it as just Blob, you get these advanced options, but this is kind of the big one that makes it a data lake. If I enable the hierarchical namespace, then it fundamentally becomes the Data Lake Storage Gen 2. So all those different additional capabilities, And then if I turn on the hierarchical namespace, well, then you can do things like enable SFTP. I can enable NFS v3. And it's telling you, hey, you need the hierarchical namespace turned on. Those things you can't change once you create the storage account. So I either turn on hierarchical namespace or I don't. I can't go and turn it on later on. So it's fundamentally changing how we're doing things within the storage account. But if I go and look at my storage browser for a second and look at Blob, it's showing me all of those containers within it. So I have a container, and notice here it looks like I've got a folder called testing. And I can go into that folder, but it's really just as part of the name of this file, it is actually putting in the name of the folder as part of that file name. There is no actual true folder system. It's just the GUI is doing a nice job for me in putting that in, but that isn't actually a true folder. It's just part of the name if I was actually go and look at the blob directly. So hierarchical namespace has true folders. Flat namespace does not. They're all virtual. It's kind of creating it ad hoc. Okay. Then we have page. Page is made up of pages, 512 bytes. It's really optimized for read-write, i.e. disks. Now, in the old days, the early Azure, we would interact with page blobs. Now we don't. We have something called managed disks, which we're going to talk about, which means that I don't typically, in most scenarios, use these anymore. Then you have append. It's a block blob, but I only add pages to the end of it. I cannot update or delete existing blocks in it. It's really useful for, imagine a log scenario. So it makes it really easy to just go and keep adding things to the end of this file. So we have block blob. And then we also have the options that I can do page, used for that really random type of interaction. And I can do append, really useful for the log type scenarios here. Now you get other capabilities as part of these services. For example, there's something called blob index tags. Blob index tags are key value pairs like the tags we have in Azure, but that's part of the Azure Resource Manager control plane. But these are actually part of the data interactions we have. And I can then use those to maybe go and find data, but I can also use it as part of the attribute-based access control we saw earlier on. So I can have things like a process date, a project, a classified, whatever makes sense. I can have up to 10, let's go and look at these. I can have up to 10 of these index tags. So if I jump back over to here, I'm just looking at images again. Let's go up a folder. If I was to just look at this particular file, we can see, well, I've got this tag here, milestone related is set to true. So it's just some piece of data that I can use. And I'm using this storage browser capability. There's also the ability to just go and scroll down under data storage and look at containers. And I get a similar kind of pretty nice view here. Then I could add a filter. So I could add a filter here. So I could type in milestone related and say, only show me where it's true. And now, as the name suggests, I'm filtering. So now it only shows me the two images where that blob index tag matched the value I specified. So it's a really good way of adding that metadata, both for maybe tracking data about the object, but maybe stuff I actually want to go and search on it as well. So it's a really cool capability to have that with the blob index tags. There's things like blob inventory. So blob inventory will go and create reports on a daily or weekly basis. So if I come out of this for a second and go to my data management, there's a blob inventory feature. And I've got a rule here. I want to inventory my blobs, and I want block and page and append. I could include versions. I can say what to store, how often I want to create the inventory, what format to output in. And then it's just going to go ahead and create me that data in my storage account. Notice I can give it full detail. It's going to put it in the inventory policy container. So if I look at my containers, I'll see inventory. I'll see these date-based folder structures get created. So I'm going to go inventory data of what my data actually looked like at any moment in time. Now, obviously, these files are going to mount up over time. So one of the things you may need to do is tidy that up. And we'll talk later on about a nice feature around lifecycle management. So you could absolutely automate clearing that stuff up. Then you get into files. So these I can interact using the various REST APIs. But files gives me an SMB or NFS share. Now, it's one or the other. When I create a share, I say, is it SMB or is it NFS? So for SMB, it's going to be a 2.1 or ideally a 3.x. The exact version varies depending on the client of how I talk to it. But I think it supports up to 3.1.1 with Server 2022 or Windows 11. Those different with version 3, it's going to be using encryption, so I can even talk to it from outside the region. SMB supports a number of different options for the authentication. It has snapshot capabilities, so I can get those previous points in time, and they will actually surface within the Windows previous versions tab. So that's a really nice set of capabilities. But SMB, remember, is built on Windows, so it's really designed to interact and authenticate using Kerberos. So there's ways I can interact with, if I have my existing Active Directory domain services, well, I can use that, and my storage account will just get an object within my Active Directory domain services. Entra ID has a Kerberos capability. Maybe my client doesn't have line of sight to my domain controllers, or there's some special scenario, I can use that. If I don't have Active Directory domain services for these accounts, I can use the Entra domain services where it's a managed set of Active Directory. And then you'd have the various access control lists on the files and folders. NFS 4.1 is some of the core features. I can only use it from a trusted virtual network because there's no encryption at transit. And again, I have to pick that when I'm actually going ahead. Now, the NFS 4.1 is only if it's a premium files account. It's also designed to only be used from Linux. Windows is not supported to actually go and use that. So if I think about my services, okay, so we had Blob, and now we also have files. And obviously files, we create a share. And at the share level, it is SMB or NFS. But remember, for NFS, it has to be premium. And then under the share, you create folders and files. So the standard stuff we're used to when we're dealing with file-based storage. Now, the next two things we're going to talk about really are being de-emphasized. So we have tables. Tables are key value sets of data. It's kind of a NoSQL. There's no set schema. I have entities, which are rows that can have whatever columns you want. But honestly, today, most customers are going to use Cosmos DB and its key value store. There's a partition key, which controls how I shard the data, partition the data. And then the partition and the row key, they uniquely identified any particular record. And then we also have queues. Queues are just messages. But again, I could use service bus queues, which are better. It's a first in, first out. So the first thing you put in should be the first thing that comes out of the queue, but it's not guaranteed. With service bus, it is guaranteed. I can only do get, put, and peek, whereas service bus has much richer subscribe, publish, as topic concepts, etc. And so these things exist, these tables and queues, but most people are starting to move away. There's not a lot of investment in them at all. So tables, hey, we have these entities that are these key value. And then we have queue, which are messages. But there's just, honestly, just better service available for those things. Just to make sure everyone's clear on what those things kind of look like. If I go and look at my storage account, and I go and look in the storage browser. So a file share, we're probably used to file shares. So I can see I've got a file share, and I would see the content in it. I'm using Entra identification. So what's giving me an issue right now? A queue. You have messages, but you put a message on the queue. You can have things like a lifetime. And I can take stuff off the queue. First in, first out, and it's gone. Tables. There's no schema. I just add values to it. And if I add an entity, it will show me things that have been used before from other objects. So it's helping me save some time. But I can add other properties I want. I don't have to enter any of those things. So there's no set schema. I can kind of add and remove things just as I choose to. So I'm going to look at particularly entity there. And those are the values I happen to put in. Those the key, the age, the value 24. Key, the alias, value, the flash. But once again, the Cosmos DB set of capabilities around this are just far, far richer today. So the queues and the tables are just not heavily used. Now you may be wondering, especially for the queue things, is like, well, when would I use queues? Then imagine I had some event-driven process. So something comes in, I can drop a message on a queue saying, oh, we received this thing. Something else, some event-driven capability would then see the message and then maybe read in some ID and then go and look and grab the actual object and do something. So in event-driven architectures, it's really common to use that queue concept to trigger that serverless Azure function or logic app or whatever you want to then go and do something with it. Money. Obviously, money is very, very important. So standard performance and Blob Premium is consumption-based. So what that means is I'm paying for the amount of actual capacity I'm using, and then I'm paying for the type of transactions that I perform against it. So if we go and look at the pricing page for this, and you can see I've got the hierarchical namespace, or it could just be the flat namespace. But from a pricing perspective, you're paying for the amount of storage. Let's actually change it to the flat for a second. So that's hierarchical. Flat is basically the same price, I think. There's a tiny bit of a price difference, tiny. And then you pay for the operations. Write operations list, read operations, data retrieval, data write. So I'm basically paying for the work I am actually doing. So that's one of the key capabilities around this. Now, you'll notice one of the key things here, and I mentioned this earlier. So the capacity prices are varying based on this. Is it premium, or then is it hot, cool, cold, and there's an archive? And it's more expensive, obviously, the better the service, which you would kind of expect. If I look at the operations are the opposite. So they're cheaper, the better it is, and they get more expensive, the lower that tier becomes. And then you have archive is an exception because archive is basically offline. Archive is, hey, I need to keep this stuff, but I don't need immediate access to it. So a key point on this element is for Blob and files, pay-as-you-go tiering impacts the capacity versus the operational cost. So those tiering capabilities let me tweak, hey, do I want to pay more for the capacity, but I know I'm going to be interacting at a certain amount, so I'll pay less for the actual transactions compared to, hey, look, I know I'm not going to be interacting with this stuff very much, but I need it available. So I want to pay the absolute minimum to store the thing, and I'm willing to pay more money for if I do actually have to interact with it. So the way this works is, let's come up here. So remember, we have different things for Blob and files. So we'll start off looking at block Blob. So if I think block Blob, an important thing for block Blob is the tier is set per blob. So many different blobs within the same container can have different tier levels. And when we think about what our options are, one of the important things is, remember, Premium doesn't have tierings. Premium is its own type of account. But I might choose Premium because I need really high performance. And again, I pay more for the capacity, but I pay a lot less for the operations against it. So I can think about, well, I have the nice Premium capability up here. Make sure I give myself enough space, actually. I know I've got to draw later on. So I might have Premium here. But then I have the concept of just the standard type of account. But within the standard type of account, well, I have a hot tier. I have a cool tier. I don't know what color to use for cool. Here we use cool tier. I have a cold tier. And then we have an archive tier. So the archive tier is, well, the best archive, and what we're kind of used to is it's barely available. Like, it's going to keep the data for us, but I can't interact with it live. So this is actually offline. So maybe I've got some data retention scenario where I have to keep data for 7 years, but I have almost zero intention of having to interact with it. So I could put it into archive. I pay almost no money. But if I do then need to read it, I have to rehydrate it back into another tier, and then I can access it. That's why they introduced cold, because originally it was hot, cold, and archive. Cold was introduced for saying, hey, look, I can't wait maybe 24 hours to move the data back into an online tier. So cold is even cheaper, but it's still online immediately. And when I think about these different options, remember then from a money perspective, I have the amount of money I pay for the capacity. So how much do I pay for the actual storage? So I pay absolutely the most for Premium, and I pay absolutely the least as I go down to kind of this archive scenario. So the price I pay for the capacity gets less and less as I go down the tiers. But the price of the operations, when I need to actually do something, well, I have to actually bring it back, but I pay a lot more compared to it's very cheap up here. So it's all about your choice. And that's obviously going to change over time as the data gets older and older. So it's very common that what I'll actually want to do is start moving data maybe down tiers. And many people put stuff in hot, and it just doesn't need to be in hot. It can actually live in cool quite happily. But it can be hard to know, well, what is the right option for that? So that's my blob is based around those. And then for files, we have similar capabilities. But if I think about files, I'm going to focus here on the pay-go. So this is my pay-as-you-go, because there's a new provisioned option which we're going to talk about. Now, the big deal here is for the tiers for files, it is a share setting. It is not a per file. So this is a share setting. And now we have three options. So we have the idea of, obviously there is the Premium kind of option again for pay-go files. But then we have within the standard option, imagine there's a line here that makes up these things. Let's just move this. Oh, come on. Do a good job. Oh, no, there we go. No. Technical difficulties. There we go. So imagine that line is going across. Within the regular, we have three options. So I can do transaction optimized. Then we can do hot. And then we can do cool. So we have those various options available to us, but I have to configure that on the share. But once again, transaction optimized, I'll pay the most for the capacity, but least for the operations, all the way going down to cool. And if we look at a storage account, So if I looked at my containers for a second and looked at images, notice my access tier, I've got some files that are hot, some are cool, some are cold, some are actually in archive. And the one that is in archive, like if I look at the hot one, I could get the file. It's letting me do it. If I try and look at the one that's archived, well, it's grayed out. It's currently archived and cannot be downloaded. I would have to rehydrate it. So I'd have to go and change the tier and move it into something else, and that will take time, and then I'd be out. So it's not instant. I think it's up to 24 hours it can take to do those operations. Any of these at any time, I can change it. Very easy. So it's a per file level. For shares, so if I go to file shares, when I create the share, that's when I have to pick. So it's a share level setting. And once again, you're going to balance that with my intended interactions with it. So if I look at the pricing for files, you can see, if we look at the provisioned V1, so that's premium, let's just do pay-go. Here we go. So the storage, I pay less as I move from to transaction optimized hot to cool. So it's cheaper to store it. But when I actually then do operations against it, it's really cheap for that transaction optimized, and it gets more expensive as I move down the tiers. So just think of these always as ways for you as the customer to optimize what I want to pay for, depending on what is my planned set of interactions with these things. So the tiers are there for you, so you can optimize actually, well, how I want to pay the money. So there's some work involved in that, and there's going to be some investigation to work out what is actually the right thing. Now, remember, that was for the standard performance and Blob Premium. It's consumption-based. So I'm going to pay for the capacity, and I'm going to pay for the operations. Files Premium and Page Blob Premium are provision-based, i.e., I pay for the amount of capacity I provision for the service, not based on the amount I'm actually using. So I say, hey, I want a 100 gigabyte premium file share. I pay for a 100 gigabyte premium file share. Doesn't matter if I've got 10 megs stored in it. I'm paying for the provisioned size of it. That's the important point. And then the performance is going to scale based on the amount of capacity. So I may pick a capacity much bigger than I want because I need the performance that gets associated with it. So for files premium and for the page blob premium, what we're doing here is it's based on, if I have a chart, I am telling it the amount of capacity. And the money I'm paying is based on the provisioned size. That's what I pay for. Doesn't matter if I'm only using 1% of it. I pay the full amount because the performance, think the IOPS, the throughput, that is going to scale based on the capacity. And so I may provision a certain size because I need this amount of storage, or I may provision this amount of size because I need the correlating performance. And that's why it doesn't care how much you use, because you may not be creating it as that size for the capacity. It's just a byproduct. What I actually need is the associated performance of it. So that's a big difference here. And it's important to know that. How am I being charged? Is it based on what I put in the thing? Or is it based on the provision size? And I pick that when I go and actually create that particular account, create that share. So it's important you understand that the difference between how those things are actually built. And then there is this new regular, today it's regular. So standard performance files provisioned v2. Now this I have to pick when I create the storage account. And now I separately pay for the provision capacity, the IOPS, and the throughput. And I can dynamically change this at any time. So now this is the file, oops, don't want to do that color. So this is files, today's standard, but it is this provisioned v2. And now I just think about it as 3 dials. I have one dial where I tell it the amount of capacity. I have another dial where I tell it the amount of IOPS. And I have another dial that is the amount of throughput I want. And I pay for what I set each of those dials to. And the nice thing is, the IOPS and the throughput are dynamic. So I can change the IOPS, I can change the throughput when I want. Now, if I increase the IOPS or the throughput, I have to wait 24 hours before I can lower it again. But I would absolutely expect this model to be coming to the premium files as well. So this gives you a lot more flexibility as the customer in what I'm paying for and how I want to pay. But just realize for Azure Storage, there are differences between how they're built. So take some time to understand that, to make sure you're picking the right thing based on the performance I need, and I'm optimizing what I'm actually paying for. And also remember, don't forget about data transfer. So when I have things that replicate to another region, there's still underlying network egress costs that I have to pay for as well. I think these get shown. Let's have a quick look. So actually, while we're here, I guess, so we're looking at files. This is the provision v2. And notice it's just bill based on the amount of provision storage, the amount of provisioned IOPS, and the amount of provisioned throughput. But if I change this to GRS, let's see. I know it shows it for Blob. Oh, yeah, data transfer. There we go. This is the bandwidth used to replicate data to the secondary Azure region. So I pay for that. So just realize when I think of all the different costs, there's also the network costs associated when I'm sending the data across the region. So if I'm planning my things out, I don't want to forget about any of those individual components. So just make sure you have that as part of your plan. Just an important point there. Okay. So I mentioned the data lake. So Azure Data Lake Storage Gen 1 was a completely different service. It did not do very well. So Azure Data Lake Storage Gen 2 builds on Blob. It adds that true hierarchical namespace to a true directory structure. And again, I can store really anything in this. I could store Parquet files, Avro, database tables, so I could store structured data. It's very common to use the Parquet, so it's that column-based storage. I could store semi-structured. I could put JSON files. I could put XML in it. I could put unstructured media, anything I want. I get a lot of the Blob features, like tiering, there's premium options, there's lifecycle management, but it's not all features. So if I go and click this for a second and we jump over and look, this will tell me which features of Blob is supported when I turn on the hierarchical namespace. And some of them are just not supported and some are in preview. And so if we go and look, so I can see access tiers. Yep, I've got access tiers. Good, good, good. I do not have Blob index tags. I have some limited Blob snapshots. Do not have custom domains. Do not have customer provided keys. Do not have object level replication. Do not have point in time restore for block blobs. So there are some things that are missing, but you can see it's pretty complete. But again, I would go and look and say, well, what are the capabilities I actually need to know exactly, well, what is going to be useful for me to go and leverage this actual data lake. But typically with a data lake, it's some raw store. if I think of data pipelines today, so data pipelines are very much used to maybe get data in from a system, do something to the data, and then send it to something else, maybe for analytics, maybe for other processing. Well, very often today, what I want to do is before I process the data, the raw source, I just go and store in a data lake. Because storage has got a lot cheaper. It used to be in the old days, storage was so expensive. And so one of the things I would have to do is, well, I can't afford to just store the data as is. It's way too expensive. And so what we would have to do is transform it, get it down to the minimum possible amount of data, and then we'd store it somewhere because those ones and zeros on disk were really, really expensive. That is not the case anymore. Today, storage is actually very, very cheap. And so here, if I think about, I have my data lake. So I've got my nice little data lake. Because I turned on the hierarchical namespace, what is super common today in my pipeline is instead of extract the data, transform it, and then load it into something, it's really common today to, as the raw data comes in, we just dump it in the data lake, as is, just store it. Because storage is so cheap. And what's nice about this is, if we store it before we transform it and maybe normalize it and validate it and throw stuff away, maybe tomorrow I have a different use case for the data. Well, if I've only stored the transform stuff, I've lost the stuff we pruned or checked away. If I store the raw data, at any time in the future, I can come back to the data lake and do a new type of analysis, a new type of transformation that I didn't think about at the time, but I have it all there. So this is why data lakes are so appealing, but we want that very good cost efficiency because it lets us do analysis that I have not yet thought about. Now, because it's built on Blob, well, I can use all of the Blob APIs. So I get a lot of flexibility in the tooling. I can use a Blob API against it. But also what we have is we have a DFS driver, so a distributed file system API. So there's a DFS API that I can use to interact with this. And what we also then have is things like Hadoop, Spark, Databricks. They have an ABFS driver, which talks to the DFS driver. This is just a fancy way of saying I can talk to this through standardized APIs that our data analysis solutions expect to use. So again, that Hadoop, the Spark, Databricks, they can all go and plug into this and leverage these sets of capabilities. So that's a really great thing that we have the option of doing. Again, it gives us that true hierarchical namespace. Now, I mentioned before that Blob, regular Blob, you see folders, but it's really just part of the file name. And you might say, well, who cares? It looks like a true folder structure to me. But if I actually try to, for example, move a file between those virtual directories in regular Blob, there is no move operation. It has to copy all those blocks to a new file and then delete the old one. So if I had a really big file and I moved it to another folder, it's a copy and delete. So it's a massive, massive operation. Whereas with the true directory structure, it's an actual metadata change. So those moves are super fast. And very often in like data analytics, we may go and move it between places based on the actual processing stage it's in. You also, I guess I should go back to my PowerPoint here. You get the true structure, you get those, you get POSIX style ACLs, so I can do the types of access control I'm used to. I can also use Entra ID identities as part of those access control lists we're putting on top of this. If we went and looked at one of these, for example, so I've got the data lake turned on, if I can find it, let's see, ADLS, I think. There we go. So on this one, if I go and look at my storage, you notice I've got some kind of different options over here. I've actually got manage ACLs. So you see I've got these POSIX style owner super user, owning group super user. I can go and add additional principals. I can go and add masks to this. So I get a different set of permission capabilities because I've turned on that hierarchical namespace. So if I have a workload that is designed for use with a true file system that wants to go and manipulate directories, for example, then the hierarchical namespace is going to make a lot more sense to you. And that's going to be a huge benefit to that particular workload. Now, from a cost perspective, it's built on Blob. And so it will always cost the same or more. It should never be cheaper than Blob. It's sitting on top of Blob. So if you're trying to work out the pricing, and you saw in the pricing page, it gave me the hierarchical namespace versus the flat namespace. It's the hierarchical namespace pricing. That's what you're going to get. But any type of analytics, any type of data transformations, Data Lake's fantastic for doing that basically dump of the raw data. And even beyond raw data, I can actually go and use it for many other things. It's very highly performant. Again, I can put those Parquet files in it, for example, as a store for my database. Hosting a website. So if I only have static content, HTML, JavaScript, cascading style sheets, images, i.e. it's all pre-rendered content that just gets sent to the web browser, the client, and it doesn't require any brain on the server side. There is no computation to generate the content. Well, then I can host it via Blob. Basically, all I have to do is at the account level, my storage account level, I can enable a static website. It shows me the URL, and it's going to create a $web folder where I put my content, and that's it. It's then going to get made available to us. Now, if we jump over and have a quick look, so I'm looking at my storage account. Let's just go back to a regular storage account for a second. So if we scroll down, we have this option, data management, static website. And we basically just say, yeah, we want it. So I'm going to say enabled. It's giving us what the URL is. And if it was GRS, we have a secondary endpoint as well. We're telling it the index name and the error page. So I'll just copy this. But if I go and look at my containers, I'll see a $web. And I just dump my content into it. Again, there's no true folders, but I can still create a subfolder, which again will be part of the Blob name. It's not going to be a problem. But then I can just dump in the URL and marvel at my fantastic website I created. I don't even know if 90s is the right word for this. But again, there's no server-side rendering. As long as it's all just stuff that the web client has to render, this is a pretty easy option to leverage. Now, this is a super, super basic option. And realistically, I can put a vanity domain in front of it. So I could absolutely have an alias record in my own domain that points to this DNS name. But there's something called Azure Static Web Apps. These are actually typically free or very cheap. It also integrates with the content delivery network. So what that means is whereas the storage account lives within a certain region, the content delivery network has points of presence and copies all around the world. So my client who's using it would talk to someone closer to them, so they actually get a better experience. Now, Azure Static Web Apps is also pre-rendered content only, but it can hook in really easily into managed Azure functions if I do want some server-side processing. So while this is nice, honestly, I'd probably just use Azure Static Web Apps instead. Access control. So we have different options for how I can control, talking to the data. Control plane, that's just regular Azure control plane, role-based access control. But for the actual talking to the data in the storage account, we have some different options. The first one is there are two all-powerful storage account keys, which ideally you do not use. If I go into my storage account and I look at my security and networking, you will see access keys. There are two of them, and they are all powerful. With these access keys, talking to the data plane, I can talk to anything and do anything within the storage account. Now you'll notice there were two of them, key 1 and key 2. And you'll also notice there's the option to rotate the key. So periodically, if I was using it, I would want to rotate it, unlike me that did it 1,000 days ago. Whoops. I don't use them. Or if you thought it'd been compromised, if someone knew it in some way, you would rotate it. Now, the reason we have two of these keys is, think about for a second my storage account. Let's go, give myself some space. So I've got my storage account. And let's say, for example, on this storage account, we're going to deal with, well, how do I control the access control of the data plane? I'm really focused on here. So we have key 1 and we have key 2. And both of them have the ability to rotate the key. So if I had to rotate the key, if I have an application using the key to talk to the storage account, well, while I'm rotating it, the application would break. So the point here is I have two. So if I plan to rotate key 1, the app would switch to use key 2. And then after key 1 is rotated, I update the app to now use key 1. So in the future, I could rotate key 2 without any interruption to my clients. So we have that option so I can do the nice rotation without breaking anything. But there is no granularity here. I can do everything. And because it's an access key, there's no good audit. If multiple people are using it, how do I know, well, which actual process or person actually did the thing? Because the auditing is just going to show the access key was used. So it's really not a good idea. I can set a reminder if I wanted to on that key rotation. If I have to use the key, ideally, put it in a key vault. Definitely never ever put it in code. That's going to apply to everything we talk about. And then I could use role-based access controls on the secret I would use to store the account key. But again, I really don't want to use it. We can disable their use. So here, notice I had this rotation reminder option that I could set up. But if I go and look at the configuration of my account, one of the nice things I could do here is I could actually disable it. So I could disable the storage account key access, so those storage account keys cannot be used. Now that has some other implications about shared access signatures, which we will talk about, but realize I can absolutely do that. I guess while we're in here, there's also this anonymous blob access. So one of the things I could also do here is say, hey, I don't want to enable this read anonymous access to my blob storage account. Now you might say, well, what's the harm in that? It's only reading. But realize even a read is an operation. So if someone spammed my storage account, just reading the data, it would cost me money. So I can block this being possible. If it's enabled like it is here, then at a storage container level, I can enable particular blob or actually list the contents of blobs in a container. So I can change the access level should I want to. But generally, we like the no anonymous access. And once again, from a configuration perspective, and I can even then use Azure policy to enforce, I probably just don't want that there at all. So we have the access keys, don't want to use them. The better option is Entra ID integration for the data plane role-based access control. And that's really available now for pretty much all of them. Blob, queue, table, files, remember, can integrate with Kerberos. For Blob, I can even add those additional conditions that we talked about when we did the identity module. So this is a much better option because then I can be a lot more granular around those permissions. So if I was, for example, right here, if I'm looking at images and access control, I could set a role assignment specific to this particular container. And if we look at the roles, let's just do blob data. All right, blob data owner, blob data contributor, blob data reader. I would see the same for queue. I would see the same for table. And the key point here, as we talked about previously, on these roles, let's say blob data reader, and I view the role, we have these actions, but remember that's the Azure control plane. But then we have these data actions. These are data plane. So this has the read blob permission on the data plane. So now if I go and look and I'm authenticating with an actual Entra ID, which is what I'm doing here. I've authenticated with my Microsoft Entra user account. I'm not using the access key. So my permission is now based on that Entra integrated authentication to what I can or can't see. So now it's based on those. So this is a much better option. And the other nice thing, remember, if I'm using things like managed identities, well, managed identity is an Entra identity. So imagine I had a computer service that wanted to go and talk to a storage account. Well, now I can just use the managed identity of the compute service and give it data plane permissions for blob or queue or table. And it would now be able to use those things. And so when I think about the different types of service for a second, so for my blob, queue, table, one of the awesome things here is Entra ID integrated role-based access control on the data plane. If I have this option, and this is available in a lot of the database offerings as well, I want to do this instead. This is the better option. And remember, for Azure Files, we talked about this before. Well, Azure Files, it likes Kerberos. And we can use our Active Directory domain services. We can use the Entra Kerberos service. If I don't have any Active Directory at all, we can use the Entra managed domain services. So I have different options, and I'm still then not using the nasty all-powerful account key. I've got other options on that. Now, additionally, if the all-powerful account key is too all-powerful, we can create shared access signatures. So think of this as a more granular set of permissions on a smaller scope. Now, one thing we can do is account. So an account shared access signature is ad hoc in that there's no policy that drives the configuration. I just have to set the things I want. And when I'm using an account, it's at the account level. So it could be for any of the types of service that exists in the account. Then there's service shared access signature. This is against a specific storage account service like Blob or Queue or Table. And that has the ability to also be based on some policy, which then if I update the policy while I've already issued this signature, it would then get updated. So I've got some flexibility there. So when I think of these options, so I can also create these shared access signatures, and I can do it at the account level, or I can do it at a service level. These account has to be ad hoc, service can be ad hoc, or service can be based on some policy that I could then update. Key point though, these shared access signatures are signed by one of the account keys. If I disable the account keys, I can't use shared access signatures. If I was to rotate the account key, it will break that shared access signature, which is in a way I can kind of revoke the thing because it's being signed and validated by that. So that's a good thing to understand from those perspectives. So let's have a quick look at these. So if I go to the storage account level for a second, I see my shared access signatures. And notice here, I'm just creating one. I'm picking, because it's the account level, I can pick whatever services I want, the types of resource, the permissions I want, start and expiry times, which IPs can use it, how it's going to be routed, which key is going to use to sign it, which is the one I would have to rotate if I wanted to kill it. And then once I've done all those various things, I would just say generate it, and it will give me that shared access signature that then when I used it, it would be good to go. I would then have that ability. If I go to a particular service, So let's say I go to a particular container. Now I have shared access tokens. So user delegation key is when I hook into things like Entra for delegated access. But once again, I'm going to sign by a certain key. It's permissions now on this particular container, but I could base it on a policy, and I can create additional policies for the various configurations I want, and I could change the policy later on to change what that given out signature actually means. But same start, expiry, IP ranges. I could then go and create the particular token, and it would then be usable for whatever this period of time was. So if I generate this, just in this, there's the URL. So just by using this URL, I would then go and have that access. So you can see it's got, if we scroll, look here, you can see the URL is obviously the particular service, then the particular container, and then it's going to have the details. You scroll over the actual signature, which is all of the control part I care about. And because it's key one, if suddenly I wanted to revoke this and it wasn't based on a policy, if I just go to my keys and just rotate key one, that shared access signature is now useless. It's been rendered because I've done that rotation. So just realize I can very easily do those things. Now, very commonly, if I'm using the ad hoc, remember I can't revoke it unless I want to go and rotate the key. I tend to keep it very short-lived, same as we do with access tokens in Entra, because they're hard to revoke. A common architecture, if I actually do want to use a shared access signature, is I have something called a valet key pattern. Some other process would go and create the shared access signature, put it, for example, in a secret in an Azure Key Vault, give the process permission to that secret, and then it will use that access point. And then there's some process that will go and update it periodically, or something has to go and request, hey, I need this permission, rather than giving some process direct ability to create those signatures. So there's a number of different things we can do to use them. But I would really, really stress, I mean, things have changed a lot. If you can, just don't use them. Like, use the data plane role-based access control. It's just such a better option. So sign of account key cannot easily revoke without regenerating the account key, as we talked about. So don't panic. Just one thing, when I showed you that shared access signature, you may be looking at that and going like, oh my God, this is sent plain text over the internet. Anyone could grab that and then they'd be able to see my signature and all my privacy is over. That's not how TLS works. Remember, that was sent over HTTPS. In reality, the way these things really work, if I have a shared access signature, if I thought for a second I've got some computer, and imagine I actually have my storage account for a second, and I had that full URL, but that's not the way, I'm not talking to the full URL. My client firstly makes a request to DNS to work out what is the IP address of the storage account, just the storage account, the host name. It then establishes a TCP session with the IP address, and then it establishes a TLS session still with the IP address. It has not sent the URL yet. All it's still talking about is to the IP address. Once it establishes the TLS session, then over that nice encrypted session, that's where it then sends the actual URL, which has the signature. So it's sent over TLS encryption. So it's never sent plain text over the internet. It's always encrypted. So just if that helps in any way, I still don't want to use them. I still rather use the data plane role-based access control, but it is not being sent plain text over the internet, which I think sometimes people get confused about. That's not the reality at all. Okay, so we're not panicking. Encryption. It's always encrypted at rest. There's no option to not have your data encrypted. Now, when I create my storage account, I can do a double encryption. And then it also uses some infrastructure level encryption. But just anyway, normally it's a 256-bit AES, which is FIPS 140-2 compliant. And the infrastructure just adds another level of encryption, which uses a different encryption algorithm, a different key, and I can go and configure this in the storage account. So if we actually jumped over for a second, if I'm in my security and networking, I look at my encryption, you can see my infrastructure encryption is disabled. But that would add a second layer, but it's only when I create the storage account. So if I was creating my storage account, so Azure encryption, at this point, I can pick Microsoft managed or customer managed. Customer managed, remember, is where the key lives within my key vault. So I'm responsible for its rotation and everything else. But then I could also turn on infrastructure encryption that would just add another level of encryption. But that is always a Microsoft managed key. So that lets me just double encrypt the storage. So that is there and available. But remember, when I'm looking at this encryption key, right now mine is Microsoft managed, but I can change it. I can change it to a customer managed, and then it's just going to be a key in my key vault, and I would just have to set the appropriate permissions so it can go and access that. So I can choose my own key in my own key vault. I can even have that key in a different tenant. So imagine a scenario maybe where I'm hosting some services for a customer. This would let the customer have the key in their key vault so they could revoke it if they wanted to. And I'm going to use that to encrypt the storage account. So in a software as a service type scenario, that would be a nice option to let the customer keep the key. And of course, if it's customer managed key, then I get to pick how often I rotate it. If I want to just revoke that thing, I have a lot more control over it. By default, a customer managed key does not apply to queue and table. It will to blob and files. If I want it for queue and table, I set that at the account creation time to say, hey, I want to use my own key. Now, this encryption key is for the entire account. But again, that SaaS solution, maybe I've got different customers in the same storage account. I can use encryption scopes. So encryption scopes let me have different sets of configuration for encryption. And then when I create a container or even upload a specific blob, I can say, actually use this encryption scope. So I could have a different, maybe it's a different Microsoft managed key. I just want different keys, or it could be different customer managed keys as part of that. So it's not just one big key for all of those different sets of capabilities. So if we jumped and had a look at this, so if I'm looking at my encryption, notice I have encryption scopes. So I've got a different scope that I'm just using a Microsoft managed key, but it will be a different key. I could add another encryption scope, and I could pick to use customer managed key, and I want infrastructure encryption. So then when I was to go ahead and let's say create a new container, as part of my advanced settings, I can say I don't want this to use the regular encryption. I want it to use this encryption scope. So I want it to use a different key. Or I could even, at a blob level, I want to upload a new blob, advanced. I want to use a different encryption scope. So at a blob level, at time of upload, I could encrypt a particular blob. So again, this is just really useful where, hey, maybe it's one storage account, but at a container level or maybe even individual blobs, I have some separation between the needs for encryption, and I can absolutely do that with this ability. So that's a pretty nice feature there. Encryption in transit can be enforced at the storage account level. So it's always encrypted at rest. I can do the double encryption. I can do different keys depending on if I want it. Encryption in transit, I need to be using TLS. So as part of the configuration of the storage account, I can enforce that. So if I go back to my storage account and I go to my configuration, one of my options here, secure transfer required. So that would require TLS when I'm talking through the APIs. It would require SMB3 if I'm using Azure Files. So it gives me that ability to control the encryption there as well. Networking. Nearly every Azure resource that's providing some service has a native firewall capability to it. and storage accounts are no exception to this. So standard features like private endpoints, service endpoints, IP-based firewalls are all available as part of my storage account. And the way this works, if you've never seen these things, so imagine, okay, let's say we have our particular storage account. So this is storage account 1. And it has its own little built-in firewall sitting in front of it. And now imagine I have my virtual network. Now remember, your virtual network is a private IP space. It is not internet routable. And so while in the firewall I can do IP-based rules, that's not useful for the IP space inside of VNet because it's this private, non-routable IP space. So the first thing we can do, imagine I have a subnet 1. And a subnet is just a portion of the IP space. I can enable service endpoints. Actually, I'm going to do it on a second subnet. So subnet 2. I'm going to say, hey, I'm going to add service endpoint for storage. And I have the flexibility to say, and this is any storage service, maybe just within a certain region. And what this does, it actually does 2 things. It gives me a more optimal routing path between the things there's only stuff in this subnet to the storage account. But now this particular subnet becomes a known entity to storage accounts, either within the region or globally. Imagine this is called VNet 1. So what this is now going to let me do is I can now say, well, actually, VNet 1, subnet 2 is allowed because I added a service endpoint, so I can now add it to the configuration of it. So now anything within here would be allowed to talk to the storage account, but things in other subnets, other networks would be blocked by its firewall. The other thing I have is something called private endpoints. So a private endpoint is an IP address. So I create a private endpoint 1, and it is configured to talk to a specific instance of a service. So in this case, I added a private endpoint for storage account 1. Now, this is just an IP address. So the difference now is that anything in this subnet can talk to the storage account. Anything that can resolve this IP address can talk to it. So it could be other things in the VNet. If I had VNet peering, if I had an express route, if I had a site-to-site VPN, if it can talk to PE1, and there's a special DNS name I need, and we'll talk about this in the networking module, as long as I can resolve it correctly so I can do the certificates required for the encryption, I'll be able to go and talk to this storage account service. So that's a really great capability as well. But there's something else we can do. So we have something called resource instance rules. And what that lets me do is that, again, my storage account level, I can say, I only want to enable a specific instance of a supported resource be allowed to talk to me. And so now what I can do is if I think of this picture again, as part of the firewall, as part of my resource instance rules, I could say something like, well, maybe I've got a SQL database. So I've got SQL 1. Maybe it's using storage as a backup mechanism. So I want SQL 1 to be allowed to talk to this storage account. So I can say, hey, SQL 1 is allowed. So that's a resource instance rule. Now, I didn't mention it. I should have done. Service endpoints also have service endpoint policies. Now, that's not really a security feature of the storage account, but imagine I had some bad actor, a bad person, trying to copy data to a rogue storage account. A service endpoint policy is something I configure on the subnet that says you're only allowed to talk to storage account 1. You can't talk to storage account 2, so you can't go and copy the software to somewhere you shouldn't. So again, not really a storage account feature, but it's a way to stop data exfiltration by someone copying data to a point they shouldn't copy it to. But yeah, the resource instance rules is just part of the network configuration. So go to networking. and I was to enable from specific networks, I can just pick that particular resource type, and then I'd be able to pick a particular instance of it. So a really nice way to lock that down. Okay, so we have all those regular networking things we can do. Then we get to lifecycle management. Now, over time, we're going to amass massive amounts of data, especially in those data lakes. And that could be that raw data from many systems, and we pay for that. We talked about the access tiers. Now, those access tiers are super useful to optimize my cost. I'll pay less for the capacity, I pay more for the interactions, but that's a lot of work to manually go and move files between the tiers. Most likely, based on a certain amount of time. Maybe it's the time it was created, maybe it's the time it was last modified, maybe it's the time it was last accessed, which means if I want to do access, I have to enable access tracking, but X number of days, move it down a tier. Now remember, Premium doesn't have any tiers. I could just delete it after a certain number of days. Append blobs don't have tiering, so I would only be able to delete it. So lifecycle management is a capability to automate some of the things we can do, but it can only do the things that the type of object is capable of. So I can't do tiering if something doesn't support tiering. But the whole goal here is lifecycle management enables rules to be defined that will automatically do things to the data. So move it between tiers, delete it after a period of time. I can use filters to limit based on the name to only do certain stuff. And those checks can be based on the creation, the modified, the access date. And what this would let me do, if I think of wherever we had tiers, I don't remember where that is anymore. Up tier, there we go. So what the nice thing I can do right here is I can do lifecycle management. So I'm going to create these rules, and I could say, well, remember with Premium, all I could do is to say, well, after X days, I could put it in the trash. That's trash, not a crown. So X days, move it to trash. But here, I could say, well, after 15 days, move it to cool. After 30 days, or let's say 45 days, I'll move it to cold. Maybe after, I don't know, 90 days, I'll move it to archive. And then maybe after 180 days, or maybe after a year, so 365 days, I'm going to go put it to the trash. So I could automate those things with lifecycle management. And this is just part of the storage account. So it's in the storage account, I'm defining these things. So if we go and look, I could go to my lifecycle management, and I just create a certain rule. So in this case, I think I've got to move data for access tiers. And you can see, what am I applying it to? I could apply different filters. And I've just got a series of rules. Hey, if it's not been accessed for 15 days, move it to cool. Not been accessed for 45, move it to cold. Not been accessed for 135, move it to archive. I don't have any deletion ones, but I could totally do that. So I could add a condition based on modified created access, then delete, because I've already used up all of the other options up there. So I can automate all of those various tasks I need to do for my storage account. So, but it is within the storage account, you see I'm creating these various policies. But now we have Azure Storage Actions. This takes it a step beyond that. It supports block, page, append for both the flat namespace and the hierarchical namespace, i.e. the data lake. It has all of the same capabilities of lifecycle management and then some. I can set immutability so you can't change it. I can set blob tags. I can undelete. I can do a whole bunch of more stuff. Same thing, if I try to use a feature that isn't supported for that type of blob, it's just not going to take effect. I can have way more complex conditions. So I can have group clauses. I can have wildcards, both star for many characters, question mark for single characters. But the nice thing here is I'm going to essentially create the tasks. So what I'm going to do here with this capability is instead of it just being this per storage account, what I'm now going to have is this ability to create these Azure Storage actions. And centrally, I'm going to create these tasks. And a task is going to be compiled of a bunch of conditions. So that's these if something, then do something. And then I'm going to assign it. So I assign it to a storage account 1. I want to assign it to storage account 2. And the nice thing here is for those assignments, I can assign these things way beyond just, for example, the sub. As long as it's the same tenant, I'm going to be able to leverage and use that thing. So that's a really powerful capability. Now, the way this works is, I guess actually quickly, while I'm in this storage account, if I look at my access control for a second, and look at my role assignments, and just search for image, you notice I have an image task that I gave storage blob data owner permission to. So this image task thing. If I now go and look at my storage account actions, I created one called image task. So it has its own identity. I have to give it permissions. So for any storage account I want it to be able to do stuff on, it has to have data plane role-based access control. But then, once I've done that, I define the conditions. So here I'm looking at the blob name ending with a certain thing, but it could start with it's empty, it equals, it matches, creation time. There's a whole sets of cool new clauses I can do. Look at these, all these different actions and things I can look at. And then I can do many different types of things. Yes, I can set tiers, but I can do legal holds, set immutability policies. I could undelete the thing. Lots of capabilities. So this much richer set of options, and then I assign it. And I can assign it basically anywhere I want within the same tenant. So as long as it's the same tenant, I can do this. So it's this much better capability to now perform things at large scale. And I pay for the storage tasks, at least I will when it's GA. But if you think about the money it may save me by centrally managing those things, that's a pretty huge capability. Okay, so what are some of the protection capabilities we have? Now, the first one is snapshots. And the whole point about snapshots is it's a point-in-time view of the blob or files share. It's read-only. It's only incremental storage. So I'm only going to pay for the changes to the data, not the entire content. But I've drawn it in gray because it's basically been killed off by a better feature. So we're going to combine a number of different features to get a better set of capabilities. Now, firstly, blob versioning. Remember we talked about, well, what is a blob? And a blob is really nothing more than a set of blocks that are chained together. So if we talk about what did we talk about? Blocks. Okay, so what is a block blob? A block blob is, we have a certain version. So it's this block, and these blocks can be different sizes. It's these blocks chained together. Great. Then I change something about this block blob. I change one block. So now I change this middle one to have some slightly different content. So now the chain is this of the blocks. But what the versioning capability does is it's like, well, this was the V1 version. This is the V2. So this is V1. These blocks are my V2 version of it. So I now get version capabilities. And once again, it's only storing the changed blocks, and the blocks can be of various sizes. So it's just this chain of different blocks. Now, it is the entire change block, But hopefully, again, it can be different sizes around those capabilities. And if we looked at the storage account, we can see we have all of these options available to us. So I'll just jump over, go and look at my data management. And if I look at my data protection, we'll see all these various options available. So the key point here is I've got versioning enabled, and I've got this blob change feed thing enabled, and I've also got this soft delete thing enabled for blobs and containers, which is then giving me this other thing over here. So we've got a whole bunch of different things that we're talking about. Now, obviously, with those versions of blobs, they're going to accrue over time. So you might use like lifecycle management we talked about to clean those up. Then we have the change feed. So the change feed, exactly as the name suggests, is really just a log of the changes. So just think of it as, hey, as I made these changes, there's a log of all the changes we're actually making as part of our environment. So it's using a special append blob. You'll see this $blob change feed. It's still in the Apache Avro format. I can pick it to delete after a certain amount of time. But now I can track at any moment in time, well, when did the changes happen? So now I've got all the versions and I know where it changed it. Then the next feature we have is soft delete. So soft delete is now saying, well, if I delete something, actually keep it. So I want to keep it for X days. And that can be at the blob level and the container level. This could be between 1 and 365 days. Now, I am going to pay for this. It's still having to store it. So I'm going to store this for a certain amount of time. But now I can undelete it. If I have blob versioning, then I'll have a soft deleted version of the blob. But again, I can still go back and I can see all those different capabilities within there. So what that means is I now have a point in time restore, which is superior to snapshots. Think about what we just drew. So if I know all of the versions of something, I know when it happened, even if I delete something, I'm keeping it. All of those together, those three capabilities, give me point in time restore. I don't have to create special snapshots. I can just randomly pick any minute I can think of within the number of days. Obviously, they're still at X days I'm doing this because this is a function of, well, how long do I keep deleted things for? How many versions am I kind of maybe pruning and cleaning things up? How long is the change feed? So it can't be longer than any of these individual things. But when I combine them together, I don't have to do snapshots now. I can go back to any point in time I want. And hey, fantastic set of capabilities there. Azure File Sync. So most of us are likely coming from Windows file shares. So the good old SMB was running on our file server. And I may have multiple file servers around my organization. Now, there's something called distributed file system replication. That's a feature of Windows to replicate between those different instances to keep them synchronized. But I can also use Azure File Sync, which uses an Azure file share as a cloud endpoint as part of this thing called a sync group. And then what I can have is up to 100 servers, like Windows file servers with a share, that become part of that sync group. There's some agent I install on the file servers that registers. And then once I've got this, it will replicate via that cloud endpoint. So my order of operations, if I think about it, is, well, I probably already got my regular Windows servers with a file share on it. I've got multiple of them. And I really want them to be kept in sync. So I go and create a file share in Azure. So this is in the cloud. I then add the agent. So there's a particular agent I add to this for the Azure File Sync. So I'm adding the agent. This now makes these show up as objects that the Azure File Sync service knows about. I'm then going to put those into a sync group. And now what's going to happen is they will replicate via the file share. Now, these are not talking directly to each other. They are replicating the data to here and both directions and there. Now, it is not designed to handle changes happening to all of these at the same time. Like, look at the get collisions. Really, it's good if one of them is the primary one you're writing to, and then it can keep these synced to up to 100 servers. Now, it's got all the ACLs in here as well. So if I have integration with a Kerberos authentication, I can also then directly talk to this, and I would have that constrained to what I have permissions to and access the data up here as well. So it could also be the backup point I actually go and talk to should there be a problem. And one of the nice things is these are probably a finite size. There's a certain amount of storage they have. So what I can also do is I can do cloud tiering. So what this says is on these local servers, I can create a policy. And what I could say here is, come on board, work, come on. There we go. I can add a policy to say, hey, I want to do tiering. And that tiering could be based on a percentage of space. So, hey, once I'm down to 20% disk space left, start tiering the least used things up to here. Or it could also be based on X number of days or some combination. It will still keep a thumbnail of the data. So I still see a shortcut to the data in the file share if I'm a client looking at it, but it's not stored here anymore. If I actually try to access the data, it would then pull it down from the file share and repopulate it into that. One caveat, it's not even a caveat, something to think about though. Windows has a nice USN journaling capability. So it makes it easy to know when something changes via that USN. There is no concept of that in Azure Files, nor is there a change notification capability. So while when there's a change made here, it's easy to just go and replicate it to Azure, there's no such concept in Azure. So what I have to do is it has a job. So there's a change detection job that runs periodically, and it does a list operations of the share, finds the changes, and will then send it down. So realize that there could be a little bit of a potential. If I originate a change up here, it could introduce a little bit of a delay to that replication. So just something to bear in mind as I think about those capabilities. Okay. A newer service, Azure Elastic SAN. Now, this is a block storage solution. Now, remember, block means the client, whatever is connecting to this, sees a disk, and it's then responsible for interacting with directly the blocks on it and having a various file system it's managing on top of that, compared to a file base where it talks to an API and just sees files and folders. And what it's leveraging is iSCSI. So iSCSI communicates over the network, so it doesn't require any special virtual hardware like it would need if it was using Fiber Channel. And iSCSI is super common. Like nearly any client can talk to iSCSI, but a big focus here for Azure Elastic SAN is things like Azure VMware Solution, where I want some external storage. I don't just want to use the virtual SAN. Azure Container Storage. It is built on regular Azure storage. This is not some storage appliance that they've bought. It's running on Azure Storage. And so when I create an instance, it can be LRS or ZRS. If we go and look for a second. So if I actually go and look at Elastic SANs and I want to create one, you'll see what I specify is a region just like everything else I ever want to create in Azure. And then I can pick the redundancy. So is it LRS or ZRS? And you'll see this idea of base units, which have an associated amount of IOPS and bandwidth, throughput. And then you just have these base capacity units that don't have any associated IOPS, but they would increase the capacity. So I get those two kind of building blocks I can leverage. So you have the base units and capacity units, and then I create volume groups and volumes. And then I would go and connect to it via iSCSI. So let's talk about our Azure Elastic SAN. So again, it's built on Azure Storage. It's going to be LRS. That's a different color. It's hard to see. LRS or ZRS for the redundancy of the data. I buy a certain number of base units. The base unit, remember, gives me capacity. And then an associated number of IOPS and throughput. But I can also just do capacity units. So maybe I've hit the performance I need, but I need a bit more storage space. So that is just capacity. Once I create the Azure Elastic SAN, I add those base units and capacity units. Within there, I create one or more volume groups. And a volume group is where I define things like the network connectivity that I want. So it's really just a network and security boundary. So on the network, I could say things like, hey, which VNets is this going to go and integrate with? Do I need private endpoints? On a security, I could say, do I want a platform managed key or customer managed key, for example? So this is a boundary for those configurations. And then within the volume group, I then go and create n number of volumes, which is just, hey, I pick the capacity for this particular volume. And then the IOPS and the throughput is going to be associated based on that capacity. And then this is what the various clients would go and connect to via iSCSI. And because it's iSCSI, I could have multiple different servers talking to the same volume. And if it was Windows, they could use it as cluster shared volumes, for example. And so it's a very cost-efficient type of storage that can be now leveraged for many different workloads. And because it's iSCSI, it's going over the network. So for my virtual machine, this counts against my network performance, not my storage performance. So that's an important thing to understand there. And then there's Azure NetApp files. Now, I said before that Azure does not use SANs, doesn't have those anywhere, except for one place. Well, this is the one place. So with Azure NetApp files, it actually has NetApp filers sitting in Azure data centers. It's a good partnership. They've got a resource provider, so it's available via ARM. And hey, I can now go and create these Azure NetApp file services in Azure. And this is maybe a good use case where either I want some kind of maybe management consistency with what I'm used to on-prem, I need a super high set of performance that I just can't achieve with regular Azure. And it provides different performance tiers depending on what I really need. So if I think with Azure NetApp files, let's go over here. So we've got Azure NetApp files. So the structure here is I create an Azure NetApp files account. Now that exists within a certain region. And then what I'm going to do is create one or more capacity pools. So I can have n number of those within that particular account. Now the capacity pool has a certain amount of capacity, the amount of storage it's going to have, but then it has something called a service level. Now that service level can be standard, it can be premium, or it can be ultra. And really just this corresponds to the performance I'm going to get based on the capacity I provision. So with standard, I'm going to get 16 megabytes per second per tebibyte. With premium, I get 64. And with ultra, I get 128. Now, something interesting they've actually done here is if these are the three sort of service levels they have, and there's no particular IOPS limit, they've added something called the call access. This isn't like when you're groovy or anything. Fonzie joke, I don't know. Imagine I have cold data across any of these different tiers. And this cold data, I specify the number of days since it's been accessed. This, I think, could be between 2 and 183 days. So it's tracking how cold the data is getting. And then it starts to package up this cold data. Again, it works on any of these into these 4 megabyte objects. And then it goes and sticks it in an Azure Storage account because it's cheaper. And that becomes this cool access. And then I can control, hey, if that happens, does it go and pull it back? And I have that capability. I pay for the capacity I'm provisioning on these things. I think I can dynamically increase and decrease. The volumes, I think 50 gigabytes is the smallest volume I can possibly have. And so, again, I got the capacity pool. And then from the capacity pool, I'm just going to go ahead and create volumes off of this. And that just has a size, a protocol. So this supports SMB, NFS, or dual. So it can actually be both of them. But the volume is 50 gigabytes up to 100 terabytes. Or there's something called a large volume that I think is up to 1 terabyte, or maybe even 2 petabytes with special things. These change a lot with Azure NetApp files. They reduce the minimums a lot and they increase the maximums a lot. So you'd want to just go and honestly check the documentation, see what the actual capability is at this moment in time. But then for a particular volume, you hook it into a particular subnet. So you're going to have your virtual network. You're going to delegate a particular subnet to Azure NetApp files, and that's how you can go and talk to it. It does have encryption in transit for NFS, but it's Kerberos integration. Obviously, it's encrypted at rest. It has all of those capabilities. But yes, it uses that delegated subnet. And it does have cross-region replication. So it has a lot of different pairs, actually. If we look at their pairings, it's not just based on the standard Azure pairings. So there's the regular Azure regional pairings that it supports, but it has non-standard pairings. So I can go in and say, well, these are the particular pairings I need based on the particular functions or the capabilities that I have in my environment. So I get a lot of nice flexibility into exactly what I want. So there we go. So those are the main storage capabilities. Now, we'll talk a lot more about this when we actually talk about virtual machines and some other services. But one of the big things is we have this concept of managed disks. This, as the name suggests, is a managed disk experience. It's abstracting away the storage account. I think I mentioned before, in ye olde days, so the ye old days with a virtual machine, what would actually happen is we would have a storage account. Remember, a storage account had certain capabilities in terms of IOPS and throughput. On the storage account, we would create a page blob, and that's what the VM would use. So what's happening here is it's basically an abstraction. There's still a storage account. There's still a page blob. We just don't see it. You only see the storage account if you try and do an import-export, where you get a shared access signature to do that behavior, and then you see the storage account name. But it's completely managed for you. What I now see is this nice managed disk thing. So this is all abstracted away. I don't have to worry about the limits of a storage account or thinking about the storage account. It's just all done for me. And this is going to be used by virtual machines, but then AKS uses virtual machine scale sets and then plug into other things. So many things will use this concept of a managed disk. So I don't worry about the storage account at all. Disks and snapshots, point in time, Delta-based storage, are just ARM-based resources. They're first-class citizens of Azure. Now, there are many different SKUs available of them. And the performance increases, the latency decreases as I kind of move up all of the different offerings from standard hard disk drive to, let's just draw these out. So if I think about managed disk, the biggest configuration I do is I do pick a capacity, but the capacity is of a certain SKU. So yes, there's going to be a certain size by picking a certain specific SKU name, but it's of a certain SKU. So at the lowest level, we have standard hard disk drive. Then we have a standard SSD. Then we have a premium SSD V1. For these three, what we're actually, now you always hear pay for the capacity provisioned, never the capacity used. So here, it's the capacity provisioned, which is the size of the disk, right? That's driving it. So that's what I pay for. And then I get an associated amount of IOPS and throughput based on the size of the disk. Makes total sense. Now, one of the other things you can do is you can increase the size of disks, but you can't shrink a disk. So with the premium SSD V1, another nice capability it has is I can actually change the performance tier separately from the capacity. So imagine I need a higher performance for maybe a shorter amount of time. I can increase the performance tier. It won't grow the disk. I'll pay for the higher size, but it won't actually increase the size. But I get the performance characteristics of what would come with the higher SKU disk. So I can change the performance tier as I may need to. If we go back to the slide, do I have the pricing? Let's click on this for a second. So this will make more sense. If we look at the pricing, for premium SSD, you're basically paying for, I don't want the V2. There we go. So I pay for a disk size and I get an associated performance. So I get these different performance characteristics. And they go up as the disk gets bigger. So what I might say is, well, look, I only want a 512 gig disk, but I need the higher performance. So I could say I want the performance characteristics of the P40, but it won't increase the disk to 2 terabytes. The disk would stay 512, but I'll get the higher set of performance that gets associated with it. So that's where I might use that performance tier capability. The other thing you'll notice is we get bursting. So I can burst up to a higher performance for a limited amount of time, and it's free for some of the tiers. So a P20, I get a free bucket of burst capability. The P30 and above, I have to pay for those buckets of burst capability. So there's different options if I need to get some higher performance. The standard SSD, I think it's the 1 terabyte and smaller, they have free bursting as well. But then they changed the model. So then we have a premium SSD V2. And we also have an ultra disk. So with both of these, what I actually pay for is the capacity, the amount of IOPS I want, and the amount of throughput I want. And these are dynamic, so I can change it as I need to. And so now I have more flexibility because I can turn the dials to say, hey, I need this amount of capacity, I need this amount of IOPS, I need this amount of throughput, and I can really just kind of tweak those things as I need to do it. And that obviously flexibility is becoming more and more common. And the whole point here is the latency, the time it takes for an operation. Like the premium SSD is sub-millisecond. The ultra disk, I think, is sub-half millisecond. So the latency gets lower and lower as I move through these tiers. So not only does the performance increase with these, the latency gets lower and lower. Because of that, all of these, none of them are geo-redundant. Like I never get geo-redundant for any of these. But with these, because the latency is so low, I only can do LRS. I can't even do ZRS for those because the time between availability zones would start to jeopardize the performance of the disk. So price based on the provisioned, not the consumed. You can dynamically increase the size of the data disks, not Ultra and Premium V2. Always check, things change with capabilities. Now, obviously, if I make a disk bigger, I then would need to, in the operating system that's talking to it, go and increase the volumes that's actually using that. There's no GRS option. Premium, SSD V2 and Ultra only have LRS. If you're using availability sets, which hopefully you're not, because we're trying to move to availability zones, but you can align the managed disk to different storage clusters based on different fault domain of the VM we talked about in the resiliency module. But all of the types of SSD and Ultra disks have a max shares property. So this enables you to have multiple VMs connecting to the same managed disk. So that's really useful if I want some sort of shared SCSI persistent reservation capability of Windows or Linux cluster, and I want the same capability there to use the same disk. I can set my own encryption. We use something called a disk encryption set. So if I think about this managed disk, imagine now I have my Azure Key Vault with my key in it. So what we're going to do is create something called disk encryption set. And we're saying this disk encryption set uses that particular key. So it's a customer managed key. And then I place managed disks into a particular disk encryption set. So they're going to use that key to unwrap the encryption material that is then actually used to get to the bits on the disks. So you do have some nice control if you need to. I can use my own encryption key on that. There's also a host encryption capability. What that would do is it would encrypt any local cache, any temp disks, the data in transit between the host the VM is on and the underlying storage. I can also do a cross-tenant custom managed key. So the key could be in a key vault in a different Entra tenant from where I've actually had my managed disk. That would be really useful in a scenario where, again, I'm that SaaS type provider and I've got storage for maybe another company. So virtual machine storage, and remember, when I create a virtual machine, when I start my VM, it's put on a certain host within a certain data center. It's using a Hyper-V hypervisor, and it gets the various CPU and memory that's associated with that VM. Now, the VM has an operating system disk that's normally durable, so it's going to be a managed disk on a hidden storage account. We may have some workloads, though, where I actually don't care about the operating system disk. Maybe I create and delete them as needed. It might be a volume VM shadow set, scale set. I'm thinking of volume shadow service. So it's a virtual machine scale set where I create and delete them as my workload changes. There's nothing special about them. They're tin soldiers. I stand them up, I knock them down. So I actually don't care about the OS. It's not a unique snowflake I care about. So one of the options we can actually do is use ephemeral storage. Providing the VM has enough cache space or temp space, it will use that to use for its operating system disk. So there's no managed disk required. That means I'm saving the cost of the managed disk, but it's also really high performance. Consider the scenario here that, okay, so I have a host. Remember that host has some local amount of storage on it, some SSD. When I start my VM, it gets created on a certain host. There's like no latency between these things. So if I can use this to store my OS, it's going to be really high performant and a really, really low latency. So realize some workloads, especially those VM scale set based ones, could be my AKS one auto scale in the cluster. If I don't care about the OS state, which I probably don't, using ephemeral storage will save me money on the managed disk. It will get created that much faster and I'll get a higher performance. So that's always an option available to me. Now, normally, most VMs have a temporary drive. This would be D or Dev SDB1 by default on Linux, but it's non-persistent. If it has temporary storage, it has the little d modifier as part of it. Windows puts the page file on it. I could use it as a scratch drive, but you don't put anything you care about on it because it could just disappear at any moment in time. Because it gets created and deleted, created, deleted every time I start or stop the VM. If I need a certain structure on it, maybe SQL was using it for a tempDB, I'd have to have some script running there to go and create whatever structure I need. But ordinarily, what's going to happen is my virtual machine, well, it's going to attach to a managed disk, for example, for the operating system. Maybe also I have some for data disks. I can set the type of caching I require. Like maybe I don't want read-write caching. Maybe I do want read-write caching. Maybe I want read caching. You have control of that. And then if it's that D variant, what you'll also get is it will attach to this for my temp drive. But again, if I shut down my VM, it disappears from this host. This VHD gets deleted. Do not put any data you care about on the temporary disk because poof, it could just go and disappear at any time. Some VM SKUs actually have NVMe local storage as well, which is super high performant. But again, it's not durable. I think the L series VMs have that. For really new VMs, you can actually use NVMe to talk to this local instead of SCSI. So again, you get higher performance, and you can even use it for, I think, the temp drive as well, for I think the V6 SKUs. Something important to remember when I think of storage is the disk has its performance characteristics. The disk has a certain amount of IOPS and throughput. Now, I could attach many, many disks to the virtual machine, which would increase the performance. But the VM also has storage performance characteristics, the number of IOPS it supports, the throughput it supports. So just throwing disks at a VM, the VM may become the bottleneck because you're exceeding its capabilities. If we go, I can actually click this. So this is going to show me the types of virtual machines. These are the naming conventions. So this is the little d. Hey, it's got a local disk. But if I go and look at a particular virtual machine size, doesn't matter which one, it will show me, so my local storage, but that doesn't have it, but remote, it has a certain performance associated with it. So if I just throw more and more disks at it, at a certain point, the VM would become the bottleneck, not the disk itself. So you need to balance those two things. VMs also have a certain number of NICs you can support, an amount of network bandwidth they can support. Now, why do I care about network bandwidth if I'm talking about storage? Well, so the VM has its NIC and it has its capabilities. If I'm talking to an SMB file share or an NFS file share or iSCSI, that goes over the network connection. That's not using, in that case, my storage performance. So make sure you remember those aspects as well, because that's a super, super important point when you're planning and sizing your workloads. If you're doing a lot of SMB or NFS or iSCSI, then you care about the network performance of your virtual machine. So you can add additional disks. Others have special types like NVMe. Remember, the VM has throughput limits as well. And some VMs have boost capabilities, so they can burst beyond their normal size things as well. I'm not really going to go into a lot of detail about this. It's there in the slides, you can look on it. But the whole point here is, and this gets a lot less likely these days with the capabilities of SSD v2 and UltraDisk. But some of the biggest VMs, I can have up to 64 disks on them. Remember, in the OS, like Windows, I can use storage spaces to combine disks. RAID sets can be a bit dodgy. I generally wouldn't use a RAID set, use a storage space. You don't need to use mirroring or parity because there's always 3 copies of the underlying disk anyway, remember. So I don't need to do those things. Things like SQL already use file groups to manage if there's multiple disks attached to it. Multiple disks would give higher IOPS and throughput than one disk, maybe. But honestly, I'm just coming down to the fact that with Premium SSD v2 and UltraDisk, it's really unlikely you actually need this. I just don't see a fantastic use case to want to get into this. From a tooling perspective, so Azure Storage Explorer is a free tool you can just go and download. I can use an account. I can use a key. I can use a shared access signature. It works with all the different types of capabilities. if you've kind of seen me use it. So if I go over to here, you can see I can go and look at a particular subscription. I can see all of my storage accounts. I can see my disks. I could go and browse around. I can do various fantastic things within here. I mean, you saw me do a lot of this stuff in the portal. I can create shared access signatures, so I can right click, and I've got nice capabilities over here to do all of the capabilities. But in the portal, we go back over, when I'm looking at a storage account, nope, storage account, there we go. We have this nice little storage browser, which is basically a web version of it. So I can do a lot of the similar things. I can go and look at a particular container. From the container, I can go and look at different capabilities within this thing. I can see all my data. I could look at file shares, queues. So it's just a nice way to actually go and interact with the capabilities. It's really easy to go and view it if you don't want to go and use an API and do those things directly. One of the really great things this actually does is, though, I can do something called server-side copying. So imagine I had 2 storage accounts. Ordinarily, if I'm a client and I'm copying, I read the data, so it downloads it from Azure, then it has to upload it to Azure. So it's hairpinning via my client. With server-side copying, it doesn't do that. It just copies directly between the storage accounts. So it's super high performance. I'm not having to now worry about it coming via my client. So it's a really, really good solution. Also, when we talk about copying data, AzCopy is a command line utility. It's free. It also uses server-to-server APIs, so it doesn't do that nasty hairpinning thing. Depending on the number of CPUs I have in my machine, I can change the concurrency to how many operations happen at the same time, so it can speed up the overall capabilities. It can use jobs to track the status of what I'm doing. It's really good to migrate data. So not only is it good for moving from on-prem to Azure, but I can do it from AWS S3 buckets, from Google storage buckets, to again migrate to Azure Storage, not from Azure Storage to those things, but certainly getting it into Azure Storage. There's also a sync mode. So the sync mode is really nice. It will detect changes from my local storage and to kind of keep them in sync. So that's a really nice capability to have there. Now, obviously, there are other storage copy solutions. Like Azure Data Factory is really, really powerful. There's cool stuff I can do there. But yeah, I mean, this is a great way to move lots of data between Azure from another cloud to Azure, keep things in sync. There's also Azure Storage Mover. So Azure Storage Mover helps me migrate from on-premises shares. So it can be SMB, it can be NFS, to Azure. So for SMB 2.0 and above, it can migrate to an Azure file share. For NFS 3 and 4, it can migrate to Azure Blob container storage. It is a fully managed migration. As an agent you deploy onto your network that has line of sight to the source. So it's basically a VM appliance you deploy down. It only has to be able to speak to Azure via 443. And what it's going to do is it will maintain everything it can about the data. So for SMB, it maintains everything. I get the full fidelity of all the metadata, any timestamps, the permissions, everything. For NFS, an empty folder will get represented as an empty blob, and the metadata of that empty folder will be stored as custom metadata on the blob. And I can work with Azure Data Box. So Azure Data Box is an offline tool. So maybe my network connection is not good enough to support moving huge amounts of data into Azure. So Azure Data Box is an offline solution to move it, but then that takes a couple of days and stuff has changed. Well, then Azure Storage Mover could replicate what had changed since that time. Which brings me nicely to import and export. I have Lots of data. I want to get into Azure or maybe out of Azure. And so what this does is there's an Azure import export. It's my disks, 2.5-inch disk SSDs, no USB drives. A single job can have up to 10 disks. I put my data on it and I send it into Azure and they put it into my storage account. It's encrypted using BitLocker. Azure Data Box disk is when Microsoft, so when I said 2.5-inch SSD only, if it's an SSD, it's only a 2.5-inch disk. But I do have choices. Azure Data Box disk is Azure provides the disks. So they're going to give you between 1 and 5 SSDs. They're 8 terabyte encrypted disks. It'll be USB 3 connection to your system, and you copy your data to it. And then for much bigger jobs, there's an Azure Data Box. So this is an appliance. Now it comes in various sizes. The original solutions with this 4U appliance that was 80 terabytes, I think, of usable space. And then there was a Data Box Heavy, which was this 500-pound unit they would ship to you that I think was 770 terabytes of usable space. So that was like a freight delivery, but obviously I could transport more data. But there's now a new generation. So there's a 120 terabyte and a 525 terabyte version of it that I can use. So again, this is an offline that gets delivered to my data center. I copy the stuff to it. I ship it back to Azure. They bring it into my storage account. And there's different capabilities depending on the solution for the source and the target that is supported. And then just finishing up, just again, not an Azure Storage feature at all, but data governance is super important. When I think about data, for most organizations, it is the most important asset you have. So I have to think about what is all of the data I have available to me. And what's happening is as companies grow, they get more IT systems, they get more data. They do not have a good handle on the data. Where is the data with PII? How did it actually get into my system? Where did it go? So how do I find my data? How do I classify the data? Maybe with my own custom classifications. How do I apply labels to it? Then how do I use data loss prevention? How do I use rights management? How do I delete stuff? Maybe I don't want to keep things that's older than a certain amount of time. So how do I do all of these different capabilities? And it's purview. And just in case I use a term rights management, and then I use the term data loss prevention. Rights management is about controlling who can access and how they can use sensitive data. So maybe I've been using encryption, maybe it's permissions, maybe it's expiration. Data loss prevention is about monitoring and preventing sensitive data being shared in a way you don't want it to be shared. So I'm restricting emails and content and maybe then alerting, maybe blocking. And I want to be able to classify and control based on the sensitivity of the data. So Purview is a data governance solution that I can use across my entire data estate. It's not just Azure, it's Azure and beyond. There's a purview.microsoft.com site. I run a discovery. I find my data. It identifies sensitive data. I can apply sensitivity labels that can then use encryption and rights management and visual markings and way, way more. There's hundreds of built-in classifications for this, or I can create my own custom classifications based on some like regex, some regular expression I want. There's a nice unified catalog, so I can easily discover and make data available. And I can use policy to help control all of that access at scale. So it's when I think about, hey, I've got this data in my organization and AI is driving a lot of focus on this, Purview is the solution for that. And so that was it. Lots covered in this one. I hope it's useful. Until next video, take care.